Okay, so remember from last year, we had three properties of logarithms, right? You have the product property, the quotient property, and the power property. Okay, so we are going to, okay, just remind ourselves that. Okay, so take a look. What is the answer to a logarithm always? Starts with an E. Exponent, right? So a logarithm is always an exponent. That means if I have here, let's say I have log base 2 of 8, okay? That tells me what is the exponent of 2 that would give me an 8, correct? Okay, now what if I had log base 2 of 8 times 4? Okay, now what I want is, what is the exponent that would give me a 32, which is what? A 5. Well, I can do that in like two different ways. The exponent that would give me an 8 is 3. The exponent that would give me a 4 is 2. But you add them, right? 5 is the exponent that would give you a 32. Okay, so do you see why we add them, right? It's because they're exponents and we're just multiplying the powers, adding the exponents. Okay, give me a few seconds. So when I have log base b of x times y, that's the exponent that would give me the x plus the exponent that would give me the y. Similarly, when I'm dividing them, it's the exponent that would give me the x minus the exponent that would give me the y. Okay? Now, if I have log base 2 of 8 squared, okay, now it's 3 to get an 8, and then times 2, 6 to get the square of that. So this comes down, so it's 2 times 3. And that's what it says here, right? Okay, so let's do these using those properties. Okay, so here we have log base 2 of 32 to the power of 1/2. The 1/2 comes down. I have log base 2 of 32. So this is 1/2. And the exponent of 2 that would give me a 32 is a 5. So that's just 5 over 2. Okay? All right, here. Yeah. Yeah. That's honestly at this stage, we're all good anyway. Yeah. So this is log base 7, 49 to the 6th, or 1/6, sorry. So the 1/6 comes down, times 3, log base 7 of 49. So this is 1/6 times 3 times 2. That's just a 1. And isn't that cool how this like seemingly like complicated little thing just turns into a 1? How cool is that? Right? I know. Okay, so okay. No joke. This triangle can't continue into semester 2. Okay? Okay. So here we had something similar to this in the homework actually. Like the 4 comes down, so 4 times 3 ln of e minus 2 times 2 ln of e. So this is 12 minus 4, 8. Okay? Okay, so how do we expand a logarithm? It's similar to the property that we just talked about. So here, ln x squared plus ln root e, right? But we need to simplify this. So the 2 will come down, 2 ln of x plus ln of e to the half, which means this is 2 ln of x plus 1/2. That's the fully simple, okay? So take a look at the next one. So first, like, identify how many elements are in the argument of the logarithm. How many elements are inside the logarithm? I have 1, cube root of x, 2, 36, 3, y to the 4. If there are 3 elements, I need to have 3 separate logarithms, right? So log base 6, cube root of x, and then everything else that's in the denominator gets a separate minus of its own. So minus log base 6 of 36 minus log base 6 of y to the 4. Yeah. You can, but then you have to like distribute. Yeah.
Why is it minus log 6 minus 4?
Okay, that's what she had started asking. So anything on top is a plus, anything on the denominator is a minus, right? So it would be minus log base 6, 36y to the 4, but then you have to separate that. So you distribute, right? So it's easier to just go with a minus for each element. So this will be log base 6, x to the 1/3, minus 2, minus the 4 comes down, log base 6, y. Okay? All right, so finally, 1/3 log base 6x. And then it's always convention to write the constants at the very end. So I'm going to write the minus 4 log 6y first, then minus 2. Is it wrong? No, it's convention. Okay, here, how many elements are in the top that we can separate? Okay, just one. Because here we have 2x minus 3. And we don't have any properties of when you have like ln of something minus something. So that whole thing is one entity. So it'll be ln of 2x minus 3. That's it. You can't distribute the ln. That is so wrong. All right? Minus the stuff in the bottom, right? So what do we have here? We have a 3, and then we have all that. So ln of 3 minus ln of this. Okay? So this is ln of 2x minus 3 minus ln of 3 minus ln of xyz to the 1/4. But now the 1/4 will come down. Minus 1/4 ln of xyz. Okay? So now, am I done? No, I still have to separate the ln of x, the ln of y, and the ln of z. So this will be ln of 2x minus 3 minus ln of 3 minus 1/4 ln of x plus ln of y plus ln of z. And I'm fine if you leave it that way. Okay? Okay, so to condense, we have to go the opposite way. However many there are, you have to combine it into one logarithm with the same base. Okay? So it's like, like going backwards, right? All the coefficients now become exponents. So I have log base 4 x to the half minus log base 4 x minus 2 cubed. Okay, so this is log base 4 x to the 4. And then since I have a minus sign, it goes in the denominator as x minus 2 cubed. Okay. It's a half. So it's root x. Okay? Okay, so whether you write x to the half or root x, that doesn't matter. Okay. Here, this goes up there, this goes up there. So I have ln of x plus 1 to the 5 times x to the 6. Okay? And you can put it in like a bracket or not. It's kind of understood. Okay, all this is from the book. Okay, the rest of this is not in your book. So we've learned how to factor out GCFs, right? But for some reason, we never get into like negative exponents, fractional exponents, and so on. So why don't we do that now? Okay? All right, so here, what can we factor out of this? We can factor out a negative 2, but I can also factor out an e to the x squared. Okay, I'm actually going to leave myself a little bit of room here. So negative 2 and e to the x squared. Now, let's go up here for a minute. If I have something like a basic 3x squared minus 6x, what can I factor out of that? A 3x. So when I factor out a 3x, instinctively, I know exactly what I'm going to get here. But in the background, what is my brain doing? It's actually dividing each term by the thing you factored out, right? So this becomes just x, and this becomes minus 2. That's what you're doing. So here too, when I'm going to factor out by negative, whatever, it's going to be negative 2 e to the x squared over, right? So you have to divide both of them by this. So now, from the first term, I have an x left plus a 3, and that's the factored answer. Okay? Same skill, just looks different. Okay? All right. Here, I'm going to factor out an x, but also e to the negative 4x. Okay, so look, I have e to the negative x, e to the negative 4x. I need to factor out the smaller number, right?
Yeah, e to the negative.
Okay. So what's smaller, negative 3 or negative 5? Yes. Okay. All right. So, yeah. We're assuming it's positive. That's a positive integer. Okay. All right. So here, okay. So what do we get when I divide by this? Huh? What? Okay, between the x squared and the x, I'm going to take out an x. That we know. Okay, between the e to the negative 4x and the negative x, I'm going to take out e to the negative 4x because that's seemingly smaller. Okay, so now, okay, go with me on this, and then I'll pause for questions, okay? So it's like dividing, x times e to the negative 4x. Okay, so from the first term, 5x squared over x, I get 5x. E to the negative 4x divided by e to the negative 4x is just the 1, so we're done with that. Minus, here I get a 2. Now, e to the negative x minus negative 4x. Do you remember when we when we divide powers, we subtract the exponents? So I get x e to the negative 4x, 5x minus 2e to the negative 5x. Oh no, 3x. Okay? Yeah. Okay. Now, yeah.
I'm just confused. Why do you pull the negative 4?
Why the what?
Why, for the exponent, why do you pull out negative?
Okay. Assume x is a positive integer. Okay? 1, 2, 3. Okay. So now, in that case, between negative 4x and negative x, which would be a smaller value? Negative 4. And so if I have, let's say, x squared and x to the 5th, how do I know how much to factor out? I only smaller number. Okay? All right? Okay.
I thought you factor out the one that they both have. Isn't that like factoring isn't factoring like taking out what like both of the terms have?
Yes. So these have e to the something else. These have e to the something x. But you have to take out the smaller one. Just like here, this has an x squared, this has an x. But they both have x's. I take out the smaller value of an x. Okay. Okay, why don't we do a whole lot more and then you guys can do the what ifs, okay? Let's do like many, many more examples and then we'll do the rest, okay? All right, so take a look here. The coefficients are a 7 and a 2, so I have nothing to factor out there. Then I have an x plus 1 term with different exponents. I have an exponent of a negative half, a negative 3 over 2, and an exponent of 1. Between these three exponents, the smaller valued exponent is negative 3 over 2. So I'm going to factor out x plus 1 to the negative 3 over 2. Then I have some x's. Some e's. Again, we're going to assume x is a positive integer, okay? I have e to the x minus 2, e to the x, e to the x. Between these three, e to the x minus 2 will have the smaller value. So I'm going to factor out e to the x minus 2. Now, as I said, factoring out means dividing by the thing I factored out. Okay, so that's what I'm doing. X plus 1, negative 3 over 2, e to the x minus 2, x plus 1, negative 3 over 2, e to the x minus 2, okay? All right, so here, I have a 7. You know what, I'm going to do a bracket here. X plus 1 to the power of negative a half minus 3 over 2. E to the x minus 2's go away. Plus, I have a 2. The x plus 1's go away. They have the identical exponents. But I have e to the x minus, in parentheses, x minus 2. Okay? Plus x plus 1 to the power of 1 minus 3 over 2, e to the x minus 2. And that's a mouthful. And guess what? Welcome to the big leagues. Okay? If you don't, so I just don't want you to go into calculus and then there's so much to deal with over there. You don't want to be, flipping over this. Okay? All right. So here, what do we have here? First of all, you cannot have negative exponents. Now, in the top, we had like negative 4x. I'll discuss that in a minute. But here, you cannot have a negative exponent here. So that has to move downstairs. So I have, e to the x minus 2 over x plus 1 to the 3 over 2. Times, let me do parentheses, brackets again. 7 times x plus 1. What's going to be the exponent there? 1. I don't have to write it. So plus 2 e to the, what is that? 2 plus x plus 1 to the power of, and e to the, right. And now it's factored. Okay? All right? That's a big thing. This is like straight out of calculus because you're going to have to like deal with this stuff over there. And again, you don't want to be like hung up on the algebra when you have other things to do. Okay, here we go. Here, I can factor out a 3, I can factor out an x, and I can factor out an e to the what? Negative 1/2, because that's the smaller number. So first term will give me a 1 plus, okay? So 9 over 3, what do we get? 3. Okay, e to the 1/2 minus minus a half is a 1. Okay, so 3x, oh, can I have e to the negative half? No, e to the 1/2, 1 plus 3e. Okay, another way of writing this is 3x, 1 plus 3e over, I don't know, root e. Both of these are okay, all right? But if you're solving like a multiple choice question, or, you know, the solution can look like anything, okay? All right, here, huh? Later. Okay, what can I factor out here? 4 minus x squared to the power of negative 1/2. So I get 4 minus x squared to the power of 1/2 minus minus 1/2. Okay, take a minute and write that stuff down, right? It's okay. Just you need to see it visually. Okay, minus x squared, and then those are identical, so they will cancel each other out. So now I have 4 minus x, oh, this is a square. Bear with me with the negative 1/2 for a minute. We'll deal with it in a second. Here I have 4 minus x squared to the 1, right? Minus x squared. Now look, they're going to combine. How cool is that? So I get 4 minus x squared to the negative half, 4 minus 2x squared. But now this has a negative exponent. It's got to move down. So finally, this will be 4 minus 2x squared over 4 minus x squared to the power of 1/2. Huh? No. Oh, here? Okay, you can factor out a 2, but since it's not going to cancel any further, there is no point in doing that, so you don't have to go anymore. One other thing before I take questions, you can also write this as 4 minus 2x squared over the square root of 4 minus x squared. Okay, yes. And then,
like, why didn't you cancel out the first 4 minus x squared?
from
Because it's a positive.
from here? Oh, yeah, because this is a positive half. This is a negative half. Is that what you mean?
I guess. Like, I don't know, like, it's just like a lot of numbers.
It's a lot of numbers.
But, like, didn't we, I don't know.
Yep.
I'm confused by, I'm confused by the second to last step to the last step. Like,
This to this?
yeah, like, I don't know. It doesn't, like, work in my
You can't have a negative exponent. Anything that has a negative exponent has to move its position and make it a positive exponent. So if it's in the numerator, it's got to move to the denominator. This stays in the numerator, this goes into the denominator. Okay, now let's go back to this one, B. This x, yes, we assumed it was a positive number, right? Usually when there's an x, you know, it could be positive or negative. So when you have this, it's okay to leave it as a negative exponent. That's why, like, that could go either way. But here, you should never have negative constants as your exponents. Okay, moving along. Okay, last one. What can I factor out? Okay, so this, it'll go away, so you get a 1. Minus 2x plus 3, 1/3 plus a third. So 2x plus 3 to the negative, huh? 1 minus 2x plus 3 to the power of 2/3. Okay, we have to bring the negative down. Huh? For which one? This one? This one?
So like,
Here?
yeah, so that's negative,
Uh-huh.
right? And so on.
So here it'll be 1/3 minus 1/3. It'll be a 1. Okay? So we get, okay, so this has to move down. Okay? So, whoops. There's a delay when I'm changing colors. So that moves down. You can write it like this. I'm just choosing to write it like that. You can also write it to the power of 1/3. Here I have 1 minus 2x plus 3. Okay? You can put it to the power of 2/3, or it could be like 1 minus cube root of 2x plus 3 squared over this, right? Same thing. Okay? Okay. Yep.
If they both, like if both of the like terms had negative exponents, would you bring everything?
Yeah.
Denominator?
Okay. So now look. We all know how to do this. A to the B times A to the C. What is that? A to the B plus C. We all know how to do that. Okay? But have we ever thought of, hey, can we go in the reverse direction? If I were to give you A to the B plus C, we could also go in the reverse direction and say, oh my God, that's just A to the B times A to the C. Okay? That's also something you're randomly going to have to do one time in calculus, one day in calculus. So why don't we just, get used to it now? So here, I have e to the x plus 4. Another way of writing that is e to the x times e to the 4. And it seems very out of context right now because we're literally like we're not going anywhere with it. But this is a big thing in calculus, okay? So here, this will be e to the negative cosine x, why not, times e to the ln of 4. But what's e to the ln of 4? 4. So this will just be 4 e to the negative cosine x, okay? So when it's, multiplication, this is a coefficient. We should write it at the beginning. It looks cleaner. This is straight out of calculus. This one, e to the kt plus c, where c is a constant. So instead of having it like, instead of having e to the kt plus 2, I have e to the kt plus c. Well, now this becomes e to the kt times e to the c. Okay? But now, what's e? What's e? Come on, you all know what e is. 2.7, blah, blah, blah. So, c is some constant. Suppose c is 2. You know e is 2.7.
I just felt so dumb.
Okay, stop. Okay, so e is a constant. Suppose, okay, it's 2.7. C is also a constant, okay? Let's suppose C was 2. So if you have 2.7 times 2, that's still some random constant, right? So I can write this whole thing as a C. Why can't I change colors? I can write this whole thing as a C because it's, what's the difference whether it's 5 or 3 or 2? So now this just becomes C e to the kt. Okay? Now look, hang on before I take questions. What was the exponential growth formula? Y equals y naught e to the kt. Guess where that comes from? It used to be some sort of derivation like this. Then you write it like this, c e to the kt, and you're like, why don't I just call that y naught? So that's like a little bit of the derivation of y naught e to the kt. Okay, that's like the coolest thing ever in math. Yeah.
I think I just like got rid of like a
Huh?
I did just get rid of this.
Okay, E is a constant. It's a number.
But
A
we know
number
what
to
number
some,
is.
huh?
We know what number it is.
Yes, we do. You're right. But we focus on the fact that it's just a constant. It's a coefficient. Okay? C is also some random number. Okay? So instead of writing a random number to the power of random number, we just write C to indicate that it's a constant. It is. Right, but C is some random number.
Yeah.
So who cares? Okay, hey, why are we talking? Okay, so yes, E is 2.7.